Hello everyone, welcome to my programming club. Today we will be solving another daily lead code problem, and problem's name is eliminate maximum number of monsters. So you are playing a video game where you are defending your city, and there is a group of n monsters that will be attacking your city. Okay, you are also given a zero indexed integer array distance which represents the distances of those monsters from the city. Also, monsters walk towards your city at a constant speed. The speed of each monster is also given to you with the help of a array speed. Okay, where speed I is the speed of the ith monster in kilometers per minute. Okay, and the distance is in kilometers also. So you have a weapon that can be once fully charged, can eliminate a monster in an instant, and it can eliminate one monster at a time. Okay, and once it have eliminated the monster, it will be discharged and it will take 1 minute to charge again. Okay, and when the weapon is fully charged, it's mentioned that it is fully charged at the starting. And let's say a monster arrives and your weapon is on charging and it have reached the full charge capacity, then also you will lose the game. Okay, so it will count as a loss. If a monster reaches the city at the exact moment the weapon is fully charged, it will count as a loss. Okay, so you have to return maximum number of monsters that you can eliminate before you lose, or let's say if you can eliminate all of the monsters, then you will return n, uh, as there are n number of monsters initially. So if you you can eliminate all of them, you will return n. So let's have a look at the constraints. The distance and speed will be of order 10 raised to power 5, length of these arrays, and distance of and speed values will be of order 10 raised to power 5. So let's see how we will be solving this problem. In this particular problem, what we can do is, one approach can be that we can find out the times at which the monster will be reaching our city. Okay, and if we find out the time at which the monster will be reaching the city, then what we can do is we can uh, store those, let's say, reach times in a min heap or say priority queue. Basically, those of you who are new to this min heap concept, I will be providing a link for article describing what min heap is, heap in general is, then min heap and max heap are its types. Okay, so min heap, right now what I can tell you is, in min heap, the smallest element is always at the root of the heap, or say top of the heap. And once you, let's say, remove this element, then heap will reconfigure itself, and again there will be such arrangement that the new root will be the minimum element. New root or say top element will be minimum. This is the case of min heap. In case of max heap, it will be reversed. So the top element will be, instead of minimum, it will be maximum. Okay, this is what min heap is. So, and according to the constraints, if we go according to the constraints, this min heap will take order of n log n to maintain. Insertion will take basically order of n log n. So if your n is here 10 raised to power 5, and even if you take, actually it's log base 2, but if you take 10 also, then it will be something like of order close to this. This is a upper bound, you can say. So your time complexity will be somewhere close to this, or you can use a log base 2 calculator to calculate it. Okay, let's say I enter the value 1, 2, 3, 4, 5. So as you can see, it's 16. In base 2, it's smaller. That's why I said that it will be upper bound if you even take log base 10. So in that case, these number of operations will be required, and it will be lesser than 10 raised to power 8 operations limit. Basically, these number of operations are allowed, and if your number of operations of your program or solution reaches equal to this limit or exceeds this limit, then you may get a TLE. So here it's lesser, so your solution will be accepted instead of getting a TLE. Okay, so once you have maintained the reaching times in sorted order with the help of min heap, sorted order of reaching times, initially your weapon will be at full charge. So you can eliminate the first monster at the 0th minute. First monster to reach city. Okay. Then for the subsequent monsters, what you will do is you will keep a variable time. Initially it will be at 0. After eliminating each monster, you will increment the time to show the recharging minute after eliminating monster. Increment time to represent recharging of weapon. Okay, so this is what we will be doing, and in any case, if times value is greater than or equal to your current reach time of monster, then in that case you will stop and you cannot kill that monster. Okay, and you will return the number of monsters that you will kill. You can keep another variable to track count how many you have killed till now. You can call it kill count. Okay, with each monster dying, you will be increasing this kill count. Okay, and that's how we will be solving the problem. Now let's implement it without further delay. So let's declare the variables. Time will be initialized to 0 and then kill count. Okay, or you can call this weapon time. Okay, and kill count will be initially 0. Then what you will do is along that you will store the size of the distance array. Distance array and speed array distance sizes will be same. We will be using that, and you will be doing a single traversal to calculate the reach times of monsters to the city, and subsequently storing them in a min heap. Let's declare the min heap also. It will be priority queue. I think it's vector. By default, priority queue in C++ will be in decreasing order. So to make it in increasing order, we have to change the syntax a little bit. So I think it will now be in increasing order. So let's call this reach times. Okay, and we will be traversing your distance and speed vectors once. So index plus, and then we will be calculating the time to reach city for current monster. So time to reach will be nothing but distance index distance at current index divided by speed, I think. Okay, and then it will be your time to reach for the current monster, and then you will be enqueuing it into your priority queue. Reach times dot push, and let's enqueue it time to reach. Okay, now you have maintained the time to reach for every monster in increasing order. The time to reach for each monster in increasing order with the help of min heap. Okay, now what you will do is you will do a simulation of the game to see how many monsters you can kill without dying. Okay, so while there is a monster present in your reach times priority queue, while it's not empty, you will do the following operations. it will be current reach time. So it will be reach times dot top, and then you will be removing it. Reach time in C++ we have to remove. In Java, basically along with the removal it will return you the value. So reach time dot pop. So this will be the current reach time of your uh, monster, and it will be the smallest one as of now. So if your times value is greater than or equal to current reach time, then in that case you will simply be returning kill count. Or else if that's not the case, you can kill the monster with the weapon, since it will be fully charged as of now. So we will simply increase the kill count, and at last we will be returning the kill count. In this will be the case you are able to eliminate all of the monsters. You are able to eliminate all of the monsters. Okay, so let's try to run for the simple test case. It's giving some kind of error. Okay, we have missed a semicolon here. Again there is some error. Reach times, I think it will be. Let's briefly check for the typos, otherwise it will give us error again. Okay, this time should be replaced with weapon time, and also we have done a little mistake also, which is that we are not increasing the weapon time to indicate charging. We will increase weapon time. Okay, uh, then weapon time to reach, I think it's fine now. Okay, this one is also replaced. So just yeah, I think it should be accepted. And there is some error. Okay, since we replaced time with this, all of the values are replaced. And here also. Yeah, it's giving error for one test case. In that case, it's saying that we will not be able to kill any monster. Okay. So we have also missed a little trivial case here, that initially your kill count will not be. If let's say this is time 0 and your kill count is also 0, then you will be returning at least 1, otherwise you will return the kill count. I think it should be accepted now. Yeah. So what mistake were we doing? That when, let's say, the first monster is reaching, then in that case, for the first monster your weapon will be fully charged. It will not take any extra time. So you should be returning one at least. So we were not doing that. Let's try to submit for the final test cases. Okay, there is some wrong answer also. Again, there is one. Okay, the mistake that we were doing was we were not considering that time can also be fractional. Okay, so let's consider a case that your distance of monster from city is 5 and your speed is 2. So in that case, you will be reaching in 2.5 seconds and your weapon will be taking 1 minute, 2.5 minutes, and your weapon will be taking 1 minute to charge. So you can take seal of this 5 by 2 instead of taking the double value, or say this decimal value. If you can take the closest integer. So the method to take that is, let's call this d denominator. So you will do 5 plus d minus 1 by d to arrive at this ceiling of value. Okay, so this will be a little change. Other than that, so this will be a change to calculate the speed times to reach, and other this is just a statement I have used for debugging. And yeah, and in case kill count is greater than 0, then you will not return the kill count. If it's 0, then you will keep incrementing it. Okay, so that's the case, and I think it will be getting accepted now. Let's try to submit for the sample test cases once. Okay, it's getting accepted, and let's try to submit for final evaluation. You can see it's getting accepted for final evaluation also. So that's how we will be solving the problem. Overall time complexity and space complexity, if you may ask, then it will be, time complexity will be order of n log n. Okay, this will be due to the priority queue that you have used, and space complexity wise it will be order of n. Okay, since you will be storing at most n monsters in this n monster reach times. Okay, and due to that typo it is also messed up a little bit. Let me rename it. Reach times. Okay, try to submit again once to see if there is no typo here. Yeah, it's getting accepted. So that's how we will be solving the problem. Okay, and if you are having any doubts or any queries in general, then please feel free to ask your doubts in the comment section. I will be more than happy to answer. So thank you for watching. Have a great day ahead.